We're going to continue our conversions of units in multiple dimensions with looking at weight and temperature. So this is going to be very similar to section 2. And so we're going to convert weights in the English system and the metric system, and then go between English and metric. And temperature, this is still English versus metric because Fahrenheit is what we use here in the US, and Celsius tends to be more of the metric. So we'll be able to convert between those two as well. So this is your conversion table that you can utilize to convert units of weight. So we can go from ounces to pounds, pounds to tons, and then we're going to use the same concept of the unit needing to be in the denominator. So the unit you're given needs to match the denominator, just like in the previous lessons. So if I want to convert weights in the English system between different ways of measuring, I can buy a 2 5/8 pound party bag of regular M&Ms for $9.99 at Walmart. Or if I'm in the theater buff, I can get a case of smaller size boxes that each have 3.4 ounces, and that costs $18.28, which has more candy. So in order to be able to make the comparison, I need to be able to compare them in the same unit of measurement. So if I'm looking at this with the same unit of measurement, it probably doesn't make sense to convert 3.4 ounces. It probably makes sense to convert, if I add all 12 boxes together, that is 40.8 ounces. I don't want to convert 2 5/8 because I don't want to deal with the fraction. So it's probably easier for me to go from ounces to pounds. So in 1 pound, there are 16 ounces. Notice that ounces is what I'm given. Ounces is what's in the denominator. So that's 2.55 pounds. Now, if I want to know what is 2 5/8 of a pound, that's roughly 2.625, because I would do 2 plus 5 divided by 8 in my calculator. So the party bag does have more candy, but only by a teeny bit. So at this point, it's probably up to you as to which bag is what you're looking for. You might be willing to pay the few extra cents to be able to do that. Another example here is we have a plane and it weighs 175 tons. It's really hard to know what does that actually mean because most of us have never lifted a ton. So we want to convert this over to something that we know. Obviously we can convert it to pounds. That would probably make a lot more sense, but the question has asked us to convert it to ounces so that we can practice a two-step conversion. So if I'm giving tons, I have to have tons in the denominator, which means that I would use 2,000 pounds in 1 ton unit conversion factor. I want to get over to ounces, and remember they have to be opposite. So pounds is in the top, which means the opposite is at the bottom. So I'm going to do 175 times 2,000 times 16, and there's my total number of ounces, which is pretty significant. Here are some other examples where we're going to convert with metric units. So we're going to go from grams to milligrams, grams to kilograms, and kilograms to grams. This works the exact same way that we looked at things in Unit 1, simply because it doesn't matter what I'm converting in the metric system, I'm using the same conversion factors always. So if we remember back from section 1, we have kilo, hecto, deca, and then we have deci, centi, and milli. So that's the order of things in there, and I would want to refer back to my notes from section 1 for those conversion factors. So the prefix milli is 3 steps away from the base unit, so which means I would multiply by 1,000. So here's base unit, 1, 2, 3. So 10, 100, 1,000. That's how I'm coming up with 1,000 there. So I do 150 times 1,000, which is 150,000 milligrams. In part B, kilo is 3 units above the base unit. So here's my base unit, and here, 1, 2, and 3. So because it is 3 units above, I'm going to divide by 1,000, and I would get 0.023. And then in part C, it's the same steps. Milli is 6 steps below kilo. So what's interesting here is I can go from a kilogram into a milligram. So I'm here at kilo. I have 1, 2, 3, 4, 5, and 6. So that is 6 steps away. So instead of going from kilo to gram and then gram to milligrams, I can actually complete the calculation, whoops, right here, by multiplying by 1 million. So it has 6 zeros because of the 6 steps. And example 4, that's pretty easy. We're going to move on to going between English and metric units now. So I have the heaviest amount ever lifted in Olympic competition was 263.5 kilograms. Nobody knows what that actually is, so let's convert it into pounds so we can find out. So the conversion factor from that slide in the beginning is there are 2.2 pounds and 1 kilogram. Kilogram has to be in the denominator because what you're given has to be in the denominator. So I take 263.5 and I multiply by 2.2, which gives me 579.7 pounds, which now makes sense to me as an English person or as an American with how much is that actually. In part B, I want to know a hummingbird weighs 1/8 of an ounce. How many grams is that? I have ounces. My denominator must also have ounces. So I'm going to do 1/8, 1 divided by 8, times 28 is 3.5 grams. So remember, fractions are really just statements of division. If I want to assess weight loss, so Megan decides that she will not go to Florida for spring break unless she loses 15 pounds in the next 3 months. Megan has a very unhealthy perspective, but that's okay. She finds an advertisement online for a British weight loss system that claims you can lose 3 kilograms per month. So in the British system, we don't use weight in pounds, we use weight in other measurements. Is that true? Will she reach her goal? So we can do this calculation by converting our pounds into kilograms and then comparing it. So if I have 3 kilograms, I would convert that by using the conversion factor of 2.2 pounds. And then times 3 months. So if I take the 3 kilograms they're estimating I'm going to lose, times 2.2, that's the amount I would lose in 1 month, times 3 is the amount I would lose in 3 months. So if the claim is accurate, which is very questionable because losing 6 point whatever pounds is a little sketchy, then Megan should say, yes, I can definitely do that. In temperature, we have what we call the Fahrenheit system. And on the Fahrenheit system, water freezes at 32 degrees and boils at 212. The difference is that Celsius actually makes more sense because water freezes at 0 and then it boils at 100, which makes more sense as far as 0 being an actual change in there. So to convert between these, we don't utilize conversion factors. Instead, we utilize equations. So I'm going to take my Celsius degrees and multiply it by 9/5 and then add 32, and that gives me the Fahrenheit temperature. If I have a Fahrenheit temperature, I will subtract 32 from it and then multiply it by 5/9, and that gives me my Celsius temperature. So here's how it actually works in preparation. In this example problem, I have 28 degrees Celsius, and I want to convert that into something meaningful in Fahrenheit because I don't have any frame of reference for how warm 28 degrees Celsius is. So I'm going to do 9/5 times 28 plus 32 using my formula, and I get 82.4 degrees. Well, now it makes sense to me that if it's 82 degrees, you can wear a swimsuit and have sunblock. In this example, a frozen pizza has to get to 450 Fahrenheit to cook, so this is what you preheat the oven to. Let's say I buy a cheap oven on eBay and it came from Romania, so now it actually measures things in Celsius. So I need to convert 450 degrees Fahrenheit into a temperature at Celsius so that I can then say what I would set my oven to. So I'm going to take 450, I'm going to subtract 32, and then I'm going to multiply it by 5/9, which gives me 232.2 degrees Celsius. So I need to set it something around there, probably around 230 degrees Celsius. So the concepts in this section are really the same as they were in section 1. It's just looking at different types of units of measurement.